So we'll go with reflection of light chapter. What is light, first of all, Gautam?
Ma'am, it enables us to see the objects.
It's a form of energy. Okay.
Yes, ma'am.
What is the use of light is it helps us to see the objects. But what it is, first of all, it's a form of energy. Like how we have heat energy, magnetic energy, electrical energy, sound energy. The same way light is also a form of energy. Okay.
Yes, ma'am.
And what is basically light, it's a kind of wave, and it requires a medium to travel. Light
Yes, ma'am.
energy, it requires medium to travel. So we call it as what kind of wave? If it requires a medium, it's called mechanical wave.
Yes, ma'am.
Okay, because it requires a medium to travel. And it travels in the form of what? It travels in the form of crust and trough.
Yes, ma'am.
Okay, so if any wave travels in the form of crust and trough, what do we call it? We call it as transverse wave.
Yes, ma'am.
Okay, and light consists of some small particles of energy. It consists of small particles of energy. What do we call them? We call them as photons.
Photons. Okay, ma'am.
Photons. Okay, photons are the particles present in the light energy. Okay, and these
Yes.
photons, they constitute some energy. Now if you take group of photons, every photon has some energy. So if you
Yes,
take
ma'am.
group of photons, it's like you are taking group of energy. So this is called quantum. What do we call this? Quantum. What is quantum actually? Quantum is actually a packet of energy.
Okay, ma'am.
Why we calling it as packet of energy? Because it is group of photons and every photon is having some energy. If you take bunch of photons, you are like breaking bunch of energy. So
Yes, ma'am.
this packet of energy is called quantum. Okay,
Yes, ma'am.
so this is the basic introduction. Fine.
Yes, ma'am.
So why do we use the light? What is the reason? Because it helps us to see the objects, to
Yes, ma'am.
see objects around us. Okay, to see objects that are around us. Okay, and how does it help us to see the objects? It is helping us to see the objects in the sense what? It causes the sensation of vision, right?
Yes, ma'am.
Sensation of vision means what? Helping to see the objects. For suppose imagine that I'm standing here. Okay, this is myself, Gautam. Okay, and there is an object in front of me. Okay,
Yes, ma'am.
now I have to see the object. So what will help me to see the object? Under what conditions I will be able to see the objects? Under two conditions. First condition, if object is emitting light. That means if objects are luminous. Luminous in the sense what? Emitting light. For suppose if it is a tube light or if it is an electrical bulb, if the object is emitting light, if object is luminous, then I will be able to see the object. Second
Yes,
case, if object is not luminous, then how will I be able to see the objects? Then
reflection type.
very good, then reflection of light will help me to see the objects. Okay,
Yes, ma'am.
if object is luminous, no issue, directly we see the rays coming from the object and we can sense it. But if object is not luminous, then how do we able to see the object? It's because of the reflection of light. And there comes our chapter. Okay,
Yes,
so
ma'am.
that is a main purpose of reflection. Reflection is playing a key role in our life. Because of reflection, because of refraction only, we are able to see the objects around us. For suppose let me take some source of light here, let it be tube light or let it be sun, whatever it is, some source of light. Okay, or maybe a candle also. So this source of light, what does it do, Gautam? It emits the radiations, right?
Yes, ma'am.
It gives out the light rays. So these are the light rays that are falling on the object. Now when they fall on the object, what happens to them? They undergo what? They undergo
Reflect.
reflection. So these rays which are falling on the object, they are called incident rays. IR means what? Incident rays. And the rays which are coming after touching the object, what do we call them? These are called RR. RR means reflected rays.
Yes,
Okay,
ma'am.
so these reflected rays, what are they doing? They are reaching our eye. Okay, so they reach our eye, so that's the reason we are able to see the object. Okay,
Yes, ma'am.
now I have a doubt, like if you see the figure, only if I take 1 2 3, this is first reflected ray, second reflected ray, third reflected ray. Only the third reflected ray is reaching my eye point, right?
Yes,
Now
ma'am.
if you take 1 and 2, these are not reaching my eye point. So will I be able to see these portions of the object now? This portion
No,
of the
ma'am.
object? No. So this portion of the object is not visible because those reflected rays, I mean the reflected rays from that part of the object is not coming to my eye. Only the
Yes, ma'am.
top reflected rays from the top portion of the object, the rays are reaching my eye.
Yes,
So
ma'am.
what is a condition for seeing the object? The condition is whether it is direct rays, if it is a source of light, or reflected rays, if it is a non-luminous object. Whatever it is, they must reach the eye, then only we will be able to see. Okay,
Yes, ma'am.
any doubt so far?
No, ma'am.
Types of objects. How many types of objects do we have basically? See, there are different classifications. We'll see the first classification. First classification is objects classified into luminous and non-luminous. Luminous objects, non-luminous objects. Luminous means glowing, non-luminous means not glowing.
Yes, ma'am.
Okay, so luminous objects means what? Which emit light.
Yes,
Which
ma'am.
which emit light, they are called luminous objects. And non-luminous means what? Which do not emit light. Which do
Yes,
not emit light. So can you tell me some examples of luminous objects?
ma'am. Sun.
Yeah, you can take sun, you can take tube light, you can take electric bulb,
Ma'am, that one insect is there.
glow worm,
Ah, yes, ma'am. Glow. Yes.
glow worm. So all these are examples of what? Luminous objects. Then what about non-luminous objects? Can you tell me examples?
Ma'am,
Like,
book, chair.
yeah, very good. You can take book, you can take table. Now I can take my pen, etc. Okay, which do not emit the light. So this is one kind of classification of objects. Okay, there is other way of classifying the objects depending on their ability to allow the light. Okay, we will see
Yes.
them now. So I think, so second classification of objects. So here objects will be classified into three types. Number one, transparent objects. We also call it as transparent medium, Gautam. Let it be object, let it be medium, all mean the same. Okay,
Okay, ma'am.
in your textbook maybe you will find it as transparent medium, all mean the same. Okay,
Yes,
transparent
ma'am.
objects, translucent objects, translucent, what is the spelling? Translucent. Okay, and third one, opaque objects. Okay, you have any idea about this?
Yes, ma'am.
Okay, so what do you know about this?
The transparent allows light to pass through them completely, ma'am.
Yeah, they allow maximum amount of light. Okay, so maximum light is allowed through these objects. Okay, the objects which allow the maximum amount of light, they are called transparent objects. And what about translucent? They allow the light partially. Okay, not completely. Opaque objects means
Do not allow.
they do not allow the light at all. Okay, is it clear?
Yes, ma'am.
Okay, now tell me some examples of transparent objects which allow the light to the maximum extent.
Ma'am, vacuum,
Yeah,
water,
you,
air.
very good. You can take vacuum, and when you take air, it must be a clear air, Gautam. Like if you take air with polluting gases, like air with smoke. When you take industrial areas, air is having some carbon particles and all. So that will be translucent medium. Okay. So I'll
Okay.
just mention clear air. Clear air is an example of transparent object. Okay. And when
Yes.
you take
Water.
still water,
Distilled water.
Still water means there is no disturbance, there is no other impurities, still water, okay, etc. You can take even diamond, okay, etc. These are the examples of what transparent objects. And what will be the examples of translucent objects? Now I
Ma'am,
can,
fog, oil, paper.
yeah, I just mention unclear air. Okay,
Yes.
it can be fog, it can be mist, it can be air with the smoke, any kind of unclear air. Okay,
Yes, ma'am.
and similarly impure water, maybe the water is having chalk dust, or maybe water is having some sand particles in it, any kind of impure water, that is also example of translucent medium. And when you take oil paper, that is also example of translucent. All these things, they allow the light partially. Okay, now,
Yes, ma'am.
so one thing you need to remember, normal glass is an example of transparent object, and ground glass, what is the difference between both of this? Composition will be different. Okay,
Yes, ma'am.
generally glass is made up of silica, SiO2, silica is present, but there will be certain small variations in composition. So you remember this, normal glass is an example of transparent object, ground glass is an example of translucent object. Okay,
Yes, ma'am.
and opaque objects which do not allow the light, what can we take? We can take the stone as an example, we can take
Bricks.
brick as an example. Now the pen which I am writing, it's an example. Okay,
Humans.
humans also. We don't take humans, because when you take light, it's an electromagnetic radiation, and x-rays, they pass through our body, no?
Okay, ma'am.
So when you take diagnostic centers, they pass x-rays, no? So we just don't consider. If you take light, it includes all kind of rays, no, Gautam?
Yes, ma'am.
Not only visible light. Visible light cannot penetrate through our body, but when you take x-rays and all, they can penetrate through our body.
Yes,
Okay,
ma'am.
so I don't take human as an example. You can take not even plastic. Plastic is translucent medium. Okay, you can take wood. You can take wood as an example. Okay, so this is second kind of classification of objects. So this classification is done based on what? This classification is done based on ability to allow the light. Getting my point?
Yes, ma'am.
Whether the objects is able to allow completely or partially, or whether they do not have the ability to allow the light, depending on this classification is done. Okay,
Yes, ma'am.
okay, third kind of classification of objects. So here objects will be classified into two categories. First category, point object. What is point object? Any idea?
Ma'am, no. Yes, ma'am. It has a common pin, ma'am. Size.
So here objects are classified into point object or extended object based on what? Based on the size of the object, whether the object is bigger in size or is it in smaller in size. Okay,
Okay, ma'am.
based on the size of the object, this classification is done. So if you take point object, what does it mean? The size of this object will be the head size of a pin. We use safety pin, no? You might have seen safety pin head.
Yes,
Okay,
ma'am.
so such
Yes,
a
ma'am.
small size. Okay, in a simple way, it's of point size, that's why it's called point object. Okay, extended object means what? Size is more than point object size. Other than point object size, let it be any height, any size, it is taken as extended object. Like if you take full stop size, it's point object. Other than full stop, 1 centimeter, 2 centimeter, 10 centimeters, whatever it is, it comes under extended object. Okay,
Yes, ma'am.
if the size of the object is more than the point object size, it is taken as extended object. Now how do we represent this point object? It is denoted as point, just denoted as one dot. Okay,
Okay, ma'am.
denoted as one dot. But when you take extended object, how is it denoted? It is denoted by an arrow mark.
Upward arrow, ma'am.
Upward arrow mark. Okay.
Yes,
It
ma'am.
depends whether you are okay, we will see different ray diagrams. Generally we take upward. Okay, sometimes they will give you below also. So what you have to take is, if this is the arrow mark, this portion is taken as head of the arrow mark, and this portion is taken as tail of the arrow mark. And if there is point object, Gautam, you just have to denote it like this, AB. Okay, now this
Yes.
AB is called what? Height of the object. Okay, and
Okay,
for
ma'am.
this object, head will be taken as arrow side, tail will be taken as the other side. Okay,
Yes, ma'am.
any doubt in this?
No, ma'am.
So this is all the different classifications of objects. First one, luminous, non-luminous. Second thing, transparent, translucent and opaque. And third classification, point object and extended object.
Yes, ma'am. Take an cardboard.
Yeah, you can take a cardboard. See, with the help of an opaque object, you can prove that light travels in a straight line.
Yes,
Okay,
ma'am.
so this is true. Rectilinear propagation means the light will be moving in a straight line path. And how do we prove that? With the help of an activity. What's that activity? We'll see now. So proof. How do we prove that it travels in a straight line? Let us do one thing. So let me take a source of light here, from which the light rays will be traveling. Okay.
Yes, ma'am.
Now see, the light rays travel in all the directions. Okay, they travel in all the directions, not in specific direction. They travel in all the directions. Okay,
Yes, ma'am.
now let me do one thing. So here I just keep an object which do not allow the light. So what do we call this object which do not allow the light?
Opaque.
It's opaque object. So when you keep opaque object, what happens here? What do we see behind it? What do we
It's
see here? We see it's a shadow here, right?
yes, ma'am.
So we see shadow of object. Why do we see the shadow? Because light rays are not passing through it, right? If light rays pass, we can have sensation of vision. If light rays are not passing, we don't have any sensation. That's why it appears dark in color, and that dark patch is nothing but shadow, right?
Yes, ma'am.
Okay, now you just imagine, if the light is changing its direction here after touching opaque object, if it is changing its direction, can't we see the object? Definitely we'll see it, right? And we don't
Yes.
find any shadow. If we are seeing the shadow, what does it mean? Light is not undergoing any deviation here. Light is passing till this point, and at this point it is not allowed, it is stopping there itself. That's it. Maybe it is
Yes.
undergoing reflection or refraction, that's a second case. But as it is opaque object, light cannot pass inside. Light is not passing inside. Okay,
Yes, ma'am.
light is not entering inside. So if it is not entering inside, how can it come outside? Outside it will not come, right? That's why back of the object we will see the shadow. So
Yes, ma'am.
shadow formation will prove that light will travel in straight line. Okay, any doubt in this?
No doubt.
Okay, fine. So we'll discuss the two theories now one by one. So first we'll discuss Newton's theory. Okay, see, both the theories, what do they explain is, they explain the nature of the light, like how light is going to be, what light is made up of, what happens to light when it touches a denser medium or a rarer medium. So all such kind of nature of the light will be explained by these theories. So first theory is Newton's theory. Okay, so he
Yes,
said
ma'am.
that light consists of particles called corpuscles. That's why it's also called Newton's corpuscular theory. Corpuscles means particles.
Yes,
Corpuscular
ma'am.
theory of light. This is a failure, okay, but this was the first theory that was proposed. So we'll just discuss it. It's a failure, it's not correct, but what was said by Newton, we will see. Okay, so what he said is, when you take light, it is made up of some particles. What are these particles called?
Full.
Actually they are photons, but he called them as corpuscles. Okay,
Okay.
during his time he called them as corpuscles. Okay, now when you take light, we sometimes see different colors, right? Like when you take the rainbow formation, we see 7 different colors, right?
Yes,
So
ma'am.
what could be the reason for those different colors? Any idea?
No.
The different colors of light is due to different wavelengths. Like if you take VIBGR, 7 different colors: violet, indigo, blue, green. Each color has different frequency and different wavelength. So because of the difference in wavelength, they have different colors. But what Newton said is the different colors of light is due to different sizes, which is wrong actually. Different size of corpuscles. Like he believed that, one particle is small, one particle is big. Which is big, it has some different color, which is small, some different color. He just believed like that, but this is completely false. Okay.
Yes, ma'am.
And he believed that, okay, these particles travel in straight line. Corpuscles travel in straight line. So this is correct point, because light travels in straight line. This is a true point. Okay. Now,
Yes, ma'am.
so what he said is, like, whenever you take these particles and they fall on our retina, they cause the sensation of vision. Okay, so let me take, this is our eye. So when light falls on the eye, what happens is it undergoes some phenomena here. What's that phenomena? It's a refraction. Okay,
Yes,
light undergoes refraction of light inside our eye. Okay, that we will discuss in coming classes. Okay, light enters into our eye, and you know that eye is made up of cornea, aqueous humor, retina. You know all about this, right, Gautam?
no, ma'am.
No? Okay, no issue. We will study. Okay, we'll study in later classes. So when you take your eye, no, you can see the white color part in the eye, right?
Yes, ma'am.
When you see somebody size, you can see white color part, that is cornea. Okay, and you see sometimes when you cry, water will come out.
Yes, ma'am.
So from where do that water will come out? It means behind back of the cornea there will be some water. Okay,
Okay,
in
ma'am.
our eye also, backside to the cornea there will be some water. It's called aqueous humor. Okay, so this light, when it enters to that water, no, it undergoes refraction of light. So these refraction of light produces refracted rays. So refracted rays, they touch the retina of our eye. After refraction we get refracted rays. They fall
Yes.
on retina, and this retina will be connected to our brain through the nerves. Now brain will understand the information, and that is how we will have sensation of vision. Okay,
Yes.
so this is all what happens. The same thing was explained by Newton. So whenever the particles fall on our eye, it undergoes some mechanical action, and because of that we will be able to see the objects. Okay, and
Yes, ma'am.
what he said is, so apart from this, what are the postulates that he said is,
Postulation, sir?
postulates in the sense, what are the points that are told by him? Like he said light is like that, like this. Those points are called postulates. Features, important points.
Okay, ma'am.
Now, so let me take a surface. Okay, let me take some wooden piece or some glass, whatever it is. Okay, now whatever it is, surface is nothing but a kind of matter, right?
Yes, ma'am.
Now what is matter made up of? Matter is made up of particles, right?
Yes, ma'am.
So there will be some particles, whether you take wooden board or whether you take pen or whether you take object cardboard, whatever it is. Okay, now what Newton said is, when light falls on the surface, what happens is it undergoes reflection of light. It undergoes reflection. When it will undergo reflection? If the particles that are present here, if they are repelling the light, light is falling on the surface and the particles are repelling it. Reflection takes place when particles are repelling it. Did you get it?
Repelling.
Repelling in the sense, what do you say, force of repulsion, beta. Repelling in the sense, అట్రాక్ట్ చేసుకోకుండా దూరంగా పంపించడం, దాన్ని రెపెల్లింగ్ అంటారు.
Like how magnets repel.
Like if you take magnet, north and north pole, south and south pole, same poles తీసుకుంటే ఏమవుతుంది, they undergo repulsion, right?
Yes,
The
ma'am.
same thing, light is falling on the surface and it undergoes reflection jarugutundi, but when it undergoes reflection, according to Newton, when the particles present in the medium are repelling it. Okay,
Yes, ma'am.
now similarly, light undergoes refraction. This is its actual path, it undergoes refraction. So when it will undergo refraction in the sense light is entering the medium. So
Yes,
what
ma'am.
what he understood is, okay, when light is entering the medium, it means that these particles are attracting the light.
Yes, ma'am.
So when particles are attracting the light, he considered like this, but this is completely wrong. Light undergoes reflection, it undergoes refraction, that is correct. But these points, due to repelling reflection takes place, due to attraction refraction takes place, this explanation is wrong.
Yes, ma'am.
Okay, is there any disturbance in my voice?
No, ma'am, it's clear, ma'am.
Okay, so this is what he said. What is wrong in this is correct, reflection refraction takes place, but these explanations are wrong. Why it undergoes reflection due to repulsion, it undergoes refraction due to attraction, all this is wrong. Okay,
Yes, ma'am.
okay, how we will prove it, let us see. Let me take this as denser medium, Gautam. Okay,
Yes.
what is denser medium, any idea?
Ma'am, it is more denser, ma'am, than the rarer.
Not like that. Denser medium in the sense, this is the medium in which speed of light increases. Okay,
It decreases, right?
in which speed, sorry, denser medium na, yes, in speed of light decreases, sorry, in which speed of light decreases, that is called denser medium. Okay,
Yes, ma'am.
now let me take here rarer medium. Light is entering from rarer medium. So what is rarer medium? It is a medium in which speed of light is,
Increasing.
yeah, in which speed of light is more. Now, if you see, according to Newton, the light is entering from rarer medium to which medium? Rarer medium to denser
Yes,
medium. So, what should happen actually? Speed of light must decrease, right?
yes,
This
ma'am.
is the correct thing. Now, if you see his points, what he said, refraction is taking place when particles are attracting. So, imagine when there is force of attraction, speed increases or decreases?
Increases, ma'am. Sorry,
Increases.
decreases.
Increases only, correct. You just imagine, Gautam, you are coming to me, suddenly I'm pulling your hand, so what happens to your speed?
Increases, ma'am.
You are coming normally, but I'm suddenly pulling your hand, so what happens? Increases, no, speed increases. So
Increases.
according to Newton, refraction is taking place due to attraction of the particles. So if you apply this point, what should happen actually? Speed must increase, right?
Yes, ma'am.
What should happen according to Newton? Speed must increase because refraction is taking place due to attraction. Whenever there is attraction, speed must increase. But in
Yes, ma'am.
reality, what happens?
It decreases.
Yeah, in reality, when it enters into denser medium, speed decreases. That is why this point is also wrong. Okay, why this point is wrong? Because Newton said that particles attract, that's why refraction takes place. But whenever particles attract, speed must increase. But in reality, speed is decreasing in denser medium. That means what he
Yes.
said is wrong. His explanation is wrong.
Yes, ma'am.
Okay, so this is what all points he said. Okay, now we will
Yes.
see his drawbacks. Drawbacks, failures, limitations all mean the same. Okay,
Yes, ma'am.
so what are the limitations? So first thing I told you, no, speed in denser medium. Speed in denser medium actually decreases.
Yes, ma'am.
Actually decreases in reality. But according to Newton, what was coming out?
It increases.
Yeah, but according to Newton, it must increase. And he did not explain this. Why Newton, why this was happening? According to you, it must increase, but actually it is decreasing. What is your explanation? Means he did not explain anything. Okay.
Yes, ma'am.
And he just said that when light falls on a surface, if there is force of attraction, light undergoes refraction. If there is force of repulsion, light undergoes reflection. But it's not like only one process takes place, right? Simultaneously both will take place, no?
Yes, ma'am.
So reflection, refraction, they take place simultaneously. Simultaneously both reflection and refraction takes place, and he did not comment on this. Both reflection and refraction happens, okay? He just believed that attraction means refraction, repulsion means reflection, but I don't know whether they will occur at same time or not. He don't have any idea, but in reality both will happen, right?
Yes, ma'am.
And one more thing, colors of the light. So when you take colors of the light, they are actually due to what? It's actually due to different wavelengths of the light. It is due to different wavelengths of the light. But what he said?
Different days. No.
But according to Newton, it is due to different sizes.
Yeah, ma'am. Different size.
This is wrong, no? Different wavelengths is responsible for different colors of the light, okay? And
Yes,
moreover,
ma'am.
he did not explain certain things like, double refraction, interference. He did not explain certain phenomena. We'll study them one by one, Gautam, okay? In the beginning
Okay, ma'am.
itself, we will not study interference, diffraction. Maybe in your 9th class or 10th class, we'll study about them, okay?
Yes, ma'am.
So he did not explain certain phenomena. What are those phenomena? He did not explain double refraction.
Polarization also.
X is beta. He did not explain polarization. Did not explain interference, diffraction, black body effect, etc., etc. There are so many. I'm just writing few here. Clear with this?
Yes, ma'am.
What he said and what are the failures of his theory? Okay. Any doubts
Yes,
so
ma'am.
far?
No doubts, ma'am.
The second person, Huygens, believed that light will be traveling in the form of waves. So
Yes,
that's
yes.
why his theory is called Huygens wave theory.
Okay, ma'am.
Huygens wave theory. Okay. So what he said, let us see his postulate. Postulates means what? Important points. Okay. So according to him, light consists of what? Light consists of waves. Crust and trough, like that. Light consists of the waves. Okay. Now,
Okay, ma'am.
he imagined the existence of ether medium. What is this ether? Huygens only must know. Nobody knows till now, Gautam. Nobody have an idea about ether. He just said that light travels in a medium called ether. Like how we have solid medium, liquid medium, gas medium, vacuum. In the same way, he just imagined one medium called ether. But in reality, so far no scientist have discovered this. He just said like that, but this is also a drawback, okay?
Yes, ma'am.
Now, and he said this point correctly. When you take different colors of light, it's due to what? It's due to different wavelengths. Is due to different wavelengths of the light. Okay. For suppose when I take visible light is consisting 7 wavelengths, Gautam. Okay. It consists of 7 different wavelengths.
Okay, ma'am.
That's why we will have 7 different colors. That is with GR. Okay. If you take violet, it will have a wavelength of 400 nanometers. If you take red, it will have a wavelength of 700 nanometers. Then what about indigo, blue, green, yellow? They will be in between 400 to 700 values. Okay. So
Okay,
different
ma'am.
wavelength, that's why different color. Okay. And he
Yes,
said
ma'am.
these points correctly. When you take speed of the light, so denser medium will be less compared to rarer medium. Speed of the light in denser medium will be less compared to the speed of light in rarer medium. And he explained successfully like reflection, refraction, Diffraction, interference. See, Newton also explained reflection and refraction, but as I said, his explanation is wrong. Reflection is because of repelling, refraction is because of attracting. That kind of explanation is wrong. But correctly, Huygens had explained. Okay, so these are all his salient features. Any doubt in this?
No, ma'am.
Okay. So we will see the limitations of Huygens wave theory. See, he successfully explained diffraction and interference, but he did not explain the other effects. Did not explain polarization, photoelectric effect. What are all these? Right now, keep it pending. You'll study in higher classes, okay?
Yes, ma'am. Yes, ma'am.
Compton effect, black body radiation. Okay. Now, one more thing, as I said you in the starting, light is a kind of mechanical wave because it requires a medium to travel, okay? And
Yes, ma'am.
of course, it can travel through vacuum also, but it also travels through medium, right?
Yes, ma'am.
Okay. So it's a kind of mechanical as well as non-mechanical. But when you ask really, ma'am, like what is the answer? Light is a kind of mechanical wave or non-mechanical wave? So the correct answer is non-mechanical wave.
I know.
Why? Because see, it can travel through medium, but does it mean that it cannot travel through, in vacuum?
It can, ma'am.
It can, right? It can also travel through vacuum where no medium is present. That's why it's non-mechanical.
Okay,
It
ma'am.
travels through medium, fine, it's a mechanical wave. But it can also travel through vacuum, right? There is no condition like light compulsory requires a medium. లైట్
Yes.
కంపల్సరీ మీడియం కావాలి అనే కండిషన్ అయితే ఏం లేదు. మీడియం లేకపోయినా వాక్యూమ్ ఉన్నా కూడా వాక్యూమ్లో కూడా పోతుంది లైట్.
Yes, ma'am.
సో ఇట్స్ అ నాన్ మెకానికల్ వేవ్. ఓకే.
Yes, ma'am.
బట్ అకార్డింగ్ టు హైగన్ he said it as what? Mechanical wave. ఇది రాంగ్.
Ma'am, one more drawback is there, ma'am. You told ether medium, right? ma'am?
Yeah, he said ether medium, but in reality no ether is existing. Okay. And one more thing, according to Huygens, he considered light as a longitudinal wave. What is longitudinal wave? Which travels in the form of compressions and rarefactions.
Yes, ma'am.
Compressions, rarefactions. Compressions, rarefactions. But in reality, what is a light? It's actually a transverse wave. Okay.
Yes, ma'am.
It travels in the form of what? It travels in the form of crust and trough. Okay. This is how it travels, not in the form of compressions and rarefactions. Okay. So the other drawback, imagination about ether. So ether is not discovered and it not existed also. He just believed that there is some medium ether, but what it is exactly, God only knows. Okay.
Yes,
So
ma'am.
these are all the drawbacks. Any doubt so far?
No doubt, ma'am.
Okay. So certain basic terminology. So first thing, optical medium. So what is optical medium? Any idea?
Ma'am,
Optical medium in the sense which allows the light. Okay.
Yes, ma'am.
Let it be partially, let it be completely, that is secondary case. But if it allows the light, it is called optical medium. Okay.
Okay, ma'am.
Now second thing, this optical medium is classified into two types. One is homogeneous medium. The other is heterogeneous medium. Homo means what? It will have same composition throughout. Heterogeneous means what? Which will have non-uniform composition. You might have studied in chemistry. Homogeneous mixture, heterogeneous mixture. Have you studied?
Yes, ma'am.
So homogeneous medium means it's an optical medium. It allows the light definitely. But how is this medium? It has uniform composition.
Yes, ma'am.
Suppose if you take diamond, throughout the diamond you take center point or corner point, wherever you take it will have the same composition. Okay.
Ma'am, even distilled water, ma'am.
Yeah, distilled water also. And heterogeneous means what? It will have non-uniform composition. So non-uniform in the sense what? If you take different portions of the medium, you will have different amounts. It will not have the same amount everywhere. Okay. For
Yes.
suppose if I take unclear air example, unclear air in the sense maybe fog, maybe mist, or maybe with smoke. So what happens here, if I take this as an environment, so here you will have some smoke particles and here you don't have any smoke particles. Okay, so here smoke is present, but in this
Yes.
region there is no smoke. So like that, non-uniform composition, somewhere it is present, somewhere it is not present, somewhere high, low, gadbad gadbad. Okay. If you take
Yes.
homogeneous, what does it mean? Wherever you take, whichever the place you take, it will have the same kind of composition. Okay. So
Yes, ma'am.
homogeneous medium, heterogeneous medium, both are optical mediums, both will allow the light, but where is the difference? The difference is in their composition. Uniform composition means homogeneous, non-uniform composition means heterogeneous. So what are the other examples of homogeneous medium? You can take glass and you can take distilled water. As you said, pure water. Distilled water is an example of homogeneous medium. And what about heterogeneous medium examples? Like as I take unclear air, maybe fog, maybe mist, maybe with the smoke. Similarly, impure water,
Yes, ma'am.
water with sand particles, water with dust particles, like that. Okay.
Yes, ma'am.
Transparent medium, translucent medium, opaque. But I think that I have this. I have explained this right in the beginning itself.
Yes, ma'am.
Different types of objects: transparent, translucent, opaque. And similarly, point source of object, extended source of object. Point source means full stop size, extended means little bigger size. Should I explain these again? Not necessary, no?
No, not required.
Okay, just instead of object, they just mentioned medium.
Yes, ma'am.
Okay, now we will see the other terms, that is ray of light. Any idea about this, Gautam?
Ma'am, a ray of light. No, no.
No, okay. So this is our sun, which is a source of energy. This is the earth planet on which we are living. Now the sun rays travel from sun to the earth, right? Now if they are traveling from sun to earth, they take certain path, right?
Yes,
For,
ma'am.
for suppose I just want to come to your home. Now I need to walk along the road or I have to ride along the road, isn't it? Similarly, if
Yes.
I want to go from Hyderabad to Tamil, I know somewhere Madurai, I have to go by train. So train has some path, that is track. Train will run on the track, isn't it? So
Yes, ma'am.
track is a path. So similarly, if you take the rays of the light, if you take sun rays, or let it be any kind of light energy, beta, let it be any kind of light energy. So the light travels along a path, isn't it?
Yes, ma'am.
So what I say is the path taken by light to travel from one point to another point. One point to another point. That is called what? That is called ray. So ray is simply what? It's simply the path taken by the light energy. Okay.
Yes, ma'am.
Now how do we represent the ray? It is represented by a straight line. Represented by a line. Okay. By a straight line. Now light has some direction, light, it travels from one point to another point. So starting point to ending point, if I take starting point A, ending point B, if light is traveling from A to B, so to know the direction, what we will be doing, we will be keeping an arrow mark like this. Okay,
Yes,
so
ma'am.
arrow indicates direction here. Where do you see the head? Head is towards B, no? So direction is towards B.
Yes, ma'am.
Okay, so arrowhead indicates the direction. Arrowhead is towards B, so direction is towards B here. Clear?
Yes, ma'am.
Now, Now what if you take group of rays?
Beam of light.
A beam of light, okay? If you take a single path, it's called a ray. If you take first path, second path, third path, so many paths, so many rays, what do we call it? It's called beam of light. So beam is nothing but bunch of rays. Bunch of rays, okay? That means you are taking group of light rays. For suppose mm, I'll just take three different categories here and then I'll explain. There are three types, Gautam. Basically, three types of beams of light will be there. First one, parallel beam of light.
Yes, ma'am.
Okay. So parallel beam, in mathematics, right? Parallel means angle of intersection is 0. Okay.
Yes.
This is first ray, second ray, third ray, fourth ray. Object A, destination B. The rays are going from A to B. Okay. So what is the
Yes, ma'am.
direction? This is the direction. Now how are the rays? This is ray 1, ray 2, ray 3, ray 4. All of them are not intersecting. So their angle of intersection is 0. So if angle of intersection is 0, we call them as parallel beam of light. Rays will be parallel. That's it in a simple way.
Yes,
Will
ma'am.
be the rays here. Rays are parallel. Parallel means what? They don't intersect at all. Angle of intersection 0. Okay.
Yes, ma'am.
Now, so second kind of beam is convergent beam. Convergent means what? Joining at one point.
From
Okay.
one
One.
source, group of light goes.
Yeah. So let me take A object. Let me take B point. So from A, the light rays are coming from different directions. But all of them, they are meeting together at point B. Okay. So
Yes,
if
ma'am.
rays coming from different directions,
Meet at one point.
meet at one point, that is called convergent beam of light. See, beam in the sense group of rays. How are those rays? They are coming from different directions, but they are meeting at one place. For suppose if you take your school, every day morning your friends will be coming. You are from maybe DRDO, I am from Hayat Nagar, maybe somebody from some different place. All of us meet at one school point, so it's called convergent. All together meeting at one place. Okay.
Yes, ma'am.
1 2 3 4 rays. Then last one, what is this? Divergent beam of light. So divergent beam of light means what? They start from one point but they go into different directions.
They
So
never meet.
yeah, this is starting point, this is the ending point. So where do they go? They start from A point, they go in different directions. Okay. So here
Yes.
rays start at one point but go into different directions. Clear?
Yes, ma'am.
Okay, so this is divergent beam. So ray is a path. If you take group of rays, it's beam. Again, in this beam we are having different kinds: parallel beam, convergent beam and divergent beam. So can you tell me what is the example of parallel beam? If you take sun rays, no beta, they are example of parallel beam. Okay.
Okay, ma'am.
Sun rays will be coming in parallel. Okay. Or else
Yes.
if you take object which is at very far distance, వెరీ నాట్ ఓన్లీ సన్, ఏ ఆబ్జెక్ట్ అయినా కానీ చాలా దూరంలో ఉంటే అక్కడ కూడా వచ్చే రేస్ ప్యారలల్గా ఉంటాయి.
Like at infinity, ma'am. Like
యా,
at infinity.
ఆబ్జెక్ట్ ఈజ్ అట్ ఇన్ఫినిటీ. ఓకే, ఆబ్జెక్ట్ ఈజ్ అట్ ఇన్ఫినిటీ కూడా ఇట్ కమ్స్ అండర్ ప్యారలల్ బీమ్. ఓకే, నవ్ సో కన్వర్జెంట్ బీమ్ వాట్ కుడ్ బి ది ఎగ్జాంపుల్ ఆఫ్ దిస్?
Ma'am, convergent.
Like if you take convex lens or when you take concave converging. Okay, either you take concave mirror or convex lens, so both will converge the rays after reflection. Okay.
Okay.
Either you can take convex mirror. not convex mirror, sorry, concave mirror or convex lens. Okay, so both of them are converging in nature. Ante when light rays fall on them, after reflection, after refraction, they make all the rays to meet at one point.
Yes, ma'am.
Okay, so when you take divergent beam, now the all other examples like convex mirror, concave lens, all of them are examples of divergent beam. Or you take burning candle
Ma'am,
flame divergent, bulb light divergent. Yes, beta.
car headlight.
Yeah, car headlight also divergent, torch light also divergent. Okay,
Yes, ma'am.
so they start at one point and they just go on widening. What about laser beam?
Laser
Laser
beam convergent.
laser light,
No, divergent.
laser light.
It's divergent, right?
It's parallel. It's parallel.
How?
Like you might have seen no red color, green color.
Yes, yes, yes.
మీకు దొరుకుతాయి కదా ఆడుకునేవి 10 రూపీస్ 15 రూపీస్.
Yes,
So
yes, ma'am.
so if you see them, mostly it is available in red color light.
Yes, ma'am. Red and yes, ma'am.
So it's parallel beam. Okay.
Parallel. Okay, ma'am.
But you have to keep at some distance. Don't get it very close. Like you take a paper and if you keep very close to the paper, it becomes divergent.
Yes,
So,
ma'am.
so normal distance, it will be parallel. Okay.
Yes, ma'am.
Now, any doubt in this?
No doubt, ma'am.
Okay. So object image, real image, virtual image, differences, pinhole camera, chala topics ఉన్నాయి. So I'll just continue this tomorrow, Gautam. Okay.
Okay,
So
ma'am.
today is class 1. I spoke to your papa yesterday. So every week I'll take 3 classes. Okay. So
Okay,
3
ma'am.
classes and 4 weeks, 3 4s are 12. So for a month I'll take 12 classes. So for this month, this is the first class. Okay.
Yes, ma'am.
Next tomorrow you will be free at what time?
Ma'am, tomorrow I have school, ma'am. So I will come at 5:30 like that.
Okay, I'll take if it is possible at 7. Okay.
Okay, ma'am. 7
Okay.
is okay, ma'am.
Yeah, and one more thing, I'll message you before 15 minutes or half an hour. If there is any substitution class for me, I may cancel the class, but mostly I'll take it. Okay.
Yes.
Okay, I don't know, right? Maybe in my college, if suddenly classes are given, I may postpone the time, but tomorrow I'll take one class. Okay. Timings I'm not sure, but I'll take tomorrow
Okay,
one
ma'am.
class. Okay. So this is what for today, Gautam. Any doubts? Any doubts from today's class? Hmm?
No doubts, ma'am.
No doubts. Okay.
No doubts, ma'am.
Okay. So I'll send the video link, okay, of today's class, because if you have any doubt, you can listen to the class. Instead of notes, I'll send directly the video link, okay?
Okay, ma'am.
Oh, okay, beta. Bye, beta.
Bye, ma'am. Thank you, ma'am.